we go. These are the 4 questions that you asked me to do in 2018. So question 1, a particle with speed 180 meters per second begins to decelerate uniformly at a certain instance while another particle starts from rest 6 seconds later and accelerates uniformly. When the second particle has travelled 165 meters, both particles have a speed of 30 meters per second. So the first particle starts at 180 meters per second and decelerates uniformly to rest. So their velocity time graph will be from 180 diagonally down to the right. Another one then starts from rest but accelerates. So he accelerates up towards the top right. And when the second particle has travelled 165 meters, both particles have a speed of 30 meters per second. So those 2 lines will intersect at a particular instance. And then you can see the shaded area represents the second particle that starts 6 seconds later. And I dropped the vertical line down there because the shaded area is the area under the line for the second particle, and that equals 165 meters. Now that's very useful because if you use a half the base by the perpendicular height there, so a half of x by 30, that'll equal 165. You get x equals 11. There we go. X equals 11. And then we know that the other particle starts 6 seconds before that. So what that means is it takes 17 seconds for the first particle to go from 180 down to 30. Using that, you can get a value for A, and then when you fill that A into V is equal to U plus AT, where the final velocity is 0, the initial velocity is 30 in that case, so they're just looking at the last section. When I did this, I looked from 180 down to the bottom, and then I subtracted the times. But look, it makes sense just to use the last triangle, or the triangle on the bottom right hand side that's white. So initial velocity is 30, final velocity is 0, acceleration from the previous part, and you get a time there of 3.25 seconds. Add that on to the 17 seconds, and it will give it the answer. Okay, 1b. 1b is phrased in a difficult manner, but it's actually a very easy question to do. We have a lorry that's that long, travels a constant acceleration. The front of the lorry passes a point P with speed U. The rear of the lorry passes P with speed V. All they're basically saying there is the lorry travels 195 meters, and in the time that it travels 195 meters, its speed goes from U to V. That's it. Like I said, it's phrased in an unusual way. And the first part is find the time taken for the lorry to pass P. I'm going to go with the marking scheme on this. There are 4 constant acceleration formula. I usually deal with the first 3, but there are 4 in the log tables. The 4th one relates S, U, V, and T directly, and if you use that formula, this comes out very quickly. So this is just an explanation of what's going on. You have R for the rear, F for the front of the lorry, and then you have this particular point P. And you're told that F passes the point with speed U, R passes the point with speed V, but in reality it's just as simple as how long does it take to travel that distance with those 2 velocities. So velocity at time 0 is U, velocity at time t is V. And like I said, go to the log tables, fill in your values, and that's what you're going to get. Now the second part. The second part of the question is what fraction of the length of the lorry passes the point P in a third of this time? So the time is equal to a third of the previous time. I would take that t value divided by 3 straight away. The acceleration is constant and we're looking to find s. What I'm thinking here is we have some sort of equation for time from the previous part. We're looking for a length of the lorry, so we're looking for s. The only formula that relates s and t is s is ut plus a half rt squared. Now, we're good to have u in it because u is already in the time equation, but there's an a in it, an acceleration. So what we need to do is relate a, u, v, and the s value because we're looking for s. So we will use v squared is u squared plus 2as, get a value for the acceleration, and then fill that in together with a third of the time taken in part 1 to get a value for s using ut plus a half rt squared. And that's what's done in that case. Okay, that's 1b completed. 2a. Now, I haven't got the question there, but off the top of my head, we're told that h is a certain distance west of k. So the first thing you want to do is draw a relative position diagram. H is the observer. I know it's the observer because in part 1 we're looking to get the velocity of k relative to h, and the second guy is the observer. So I draw their positions. I just put the 2 dots on an ij axis. My next step then with these questions is get the velocity of h and the velocity of k. So I've done that here and here. And then we're looking for the velocity of kh, so it's the velocity of k minus velocity of h. There may be a mistake there because I did it while I was distracted. And what we need to do is get the magnitude and the direction. Now the magnitude will be used later on for speed is distance over time to get the time taken for k to get to the shortest distance, and the time taken for k to get to the distance where it's 40 meters from h. The direction is always essential in these questions because you need the angle that the relative velocity vector is taking from k relative to h, and that diagram is essential. So the first thing you do, relative positions, then you get the relative velocity vector, fill in the relative velocity vector at the first one in this relative velocity formula. All right, so we need the shortest distance if we're going to complete part 2. And part 2 is the time taken for k to get to a point where it's 40 meters from h. So right now it's 48.5. If it gets to this point relative to h, it'll be 40 meters away. But in order to do that, we need to see where the shortest distance between h and k will be, so the perpendicular distance. Because we'll need this triangle here with that value to get this length there. So if we use the triangle that I'm outlining there, HK, I think that's S, then sine of 53.6 is the shortest distance, which is HS. Over that, the shortest distance, HS, look, shortest distance is 39.04. You then use Pythagoras with that length, and that length. And what you want to do is, that's 40, that's 39.04. You need that distance. Once you have that distance, you double it. So that will give you the total distance there. And once you have the total distance and you have the speed as well, you divide the total distance by the speed to give you the time that the two particles are able to exchange signals. And if you're wondering where the 17.4 comes from, it's twice Sx, because Sy and Sx are the same. The other thing we're looking for is how long does it take for k to be able to exchange signals. So we're looking for the time taken to go from k to x. So we need that length as well. And you would just use trigonometry to get that distance. You'd use the speed again, and you do speed as distance over time. Sort that out, and it takes 1.123 hours for k to get to x. Okay. 2b. So this is a relative wind question. If it's a relative wind question, you're given information twice. In the first instance, you're told the man is walking with 25 meters per second north of a speed, and the velocity of the wind relative to the man appears to be going east. We don't know the speed, so we just call it x. In the second instance, the velocity of the man, he's walking west with a speed of 9.35, so that's minus 9.35 in the I direction, and the velocity of the wind appears to be going towards the northeast. So if it's going to the northeast, it's probably going to be a different speed to the one previously. In other words, he's experiencing the wind traveling at a different speed to when he's traveling in the first instance. And because it's going at a 45-degree angle, I've said that the velocity is going to be y times the cos of 45, which is y over root 2 in the I direction, and the same then in the j direction, but sine 45 is 1 over root 2. We apply the velocity of the wind is the sum of the other two vectors twice. So we add those together, and I get an equation like this. The i's are equal, the j's are equal, so y is equal to 25 root 2. Fill that in there, so we get 25 minus that is equal to x. X works out as 15.65. So the velocity of the wind is 15.65 plus 25, which is what we have there. Now in part 2, we can use the velocity of the wind there because it's the actual velocity of the wind. We're told then that the man has got a particular velocity, and we're asked to find the velocity of the wind relative to the man. So you would use the formula velocity of wind relative to the man is the velocity of the wind minus the velocity of the man. So you're subtracting those, you get that, and then the direction is just the j component over the I component and get the inverse tan of it. Job done. All right. Now this is the first video because it'll stretch on a bit too long if I continue going. So I'll continue in a second video.